that will prompt you to enter a network password. The password is listed on the back of the label, which I won't say on the live cast, but it is the same for everyone. That will take you to the gateway. On the gateway screen, you'll be prompted for your individual username and password. The email, which may or may not be the email that you use for Eventbrite. If you have attended another event previously, they append digits, so double check that there's not a number at the end of your email address. Then you'll enter the password that's there, which was randomly generated. Kosher? Okay.
All right. So we're going to do, as they reboot the computer and the live streaming network for the video, we're going to do Q&A, I think. So does that mean that the mics on the tables are working? So the mics on the tables are working. Do you, why don't you start with a question? Kick it off.
So my name is Satoshi Nakamoto. They've dealt with me. You've heard that joke for a few times. So this is an open forum. Right now, Vitalik's at Mobile World Congress, so we have a video of him that we're going to be sharing with you, but there's a technical difficulty, so we're going to do that afterwards. But this is an open format for you to ask us questions, and then we're going to flip the tables and ask you a few questions. So with that, open floor.
Here comes a question.
Hi, my name is William Ogayar. Can you elaborate more on the benefits of having the public and the private permission blockchains work together? Yeah.
Go ahead.
So I think it's good to just map kind of what public Ethereum and the public Ethereum Foundation is working on before we kind of talk about how we can merge the two. So the Ethereum Foundation's purview is really scalability and privacy of the public Ethereum mainnet. So for public Ethereum, there are really 3 milestones within the scalability roadmap, incorporating which Heiko is working on, proof of stake, changing the consensus algorithm from proof of work, proof of stake, and then finally quadratic sharding, where basically shards of the network can form consensus rather than the whole network. And then on the privacy side, it's incorporating zero-knowledge proofs, or ZK snarks, into the protocol. And basically, there's a lot of that work that's being done, and the Ethereum Foundation is quite justly overwhelmed with that work. And we're going to see 2 out of the 3 milestones of scalability and proof of stake and state channel is probably incorporated in the next 12 months. And we will see ZK snarks incorporated probably as well in the next 12 months. And then basically we'll be waiting for sharding. But all that being said, what we're doing is we're creating a venue for which enterprises can work on standard protocols while that is being completed. So we're going to have permissioning, privacy, and
pluggable consensus.
Pluggable consensus. So that's really.
Yeah. Let me jump in. So I think there's medium term and then longer term on this. In the medium term, in the immediate term, the benefit of the public network is what we already have. And that is we have a very solid protocol. We've got strong development tools. We've got software that works. None of that would exist without the crypto economics of the public network. The reason why Ethereum has so many more developers than any other blockchain protocol is because of the crypto economics of the public chain. However, but those crypto economics are strong incentives for the elements that Andrew discussed. That we need something also to power in enterprise requirements, which are developed slightly differently, right? So the short-term benefit is we already have Ethereum, and that's a huge short-term benefit. In the medium term, there is the Ethereum core roadmap that Andrew outlined, and then there's what can you do between a private permissioned Ethereum network today and have it interoperate with the public net. So things like anchoring, right? Things like using this as a gateway to get from one place to the other. And then there's the long-term version. Now, I would argue in the long term, there won't be this debate. You're going to have a protocol, and it will have privacy, and it will have permissioning, and it will enable for consensus to be formed in a variety of ways. And at that point, the difference between a private network and a public network is a firewall. It's not a difference at the protocol level, right? but that's the long term. And so what's important for us to get from where we are today to the long term is for us to have a deep understanding of the Ethereum roadmap, as Andrew outlined, and to make sure that we're building in parallel. So in the sessions that we've been having, Vitalik has been instrumental in driving the initial development priorities for the roadmap. So for example, we talk about pluggable consensus. In order to have pluggable consensus, before you can do pluggable consensus, you need to have a much more structured and modular Ethereum virtual machine, a much more structured and modular Ethereum client. Because in order to be able to plug and play components, you need to have interoperable APIs, right? It's just basic object-oriented programming issues. In fact, not even object-oriented, basic programming issues, right? So the first thing, and we're going to talk about this in the roadmap, but one of the very first things that we're doing is cleaning up an Ethereum client, cleaning up Pytherium. Now that also benefits what Vitalik's trying to do, because in order to do proof of stake, it would be one way you could do it is take an existing client and look in the internal codes and comment out the proof of work bit and then insert your additional code. But a more elegant way to do that is to have a refactored client with strong interfaces and plug it in that way. That we both benefit from having alignment on roadmap and being able to deploy more resources to the shared problems, like having a modular client. So having a highly modularized Ethereum client is not on the list of main priorities for the EEA, but it turns out to be something very important for achieving what we want to do, and it turns out to be an important priority for Vitalik. So it's very easy for us to collaborate on that. So in the short term, we have Ethereum, which is only here because of the public network. In the medium term, we have this idea of having shared roadmaps, or we understand what they're doing, we focus on problems that are mutual, and we develop what enterprises need as well. And in the long term, I would argue the difference between a private network and a public network is simply a firewall configuration. And the technology will mature sufficiently that we get to that point.
Just a comment to end your comments. I think this is one of the unique differentiations of what's going on right now. There's no other blockchains out there that will have the interoperability between public and private. Not even Bitcoin is going to come close to it. So I think this is, in my opinion, the strongest, one of the strongest benefits of what you're doing in terms of tying in the long term, the benefits of not just having the same standards, but also working together from a user perspective.
Is this going to be like a Java, J2EE? You're going to build an enterprise version of Ethereum?
So yes and no. So J2EE did some things wrong. So where the parallel is this idea that Java was built for one thing and got repurposed for something else, and it needed a standard to scale the community around that. And until you got to the standard, you couldn't scale the tools. So had things like JMX and JAS and JMS and a whole bunch of things develop out of J2EE, which gave you enterprise infrastructure for building websites, right? So I think that part of the analogy may hold, but Java, the J2EE birthing process was somewhat unnatural in that the standard was really developed by a single vendor. It was then repatriated into Sun. Right? The standard was really developed by WebLogic and BEA. It wasn't really developed by a community. It was then repatriated into Sun. Oh, sorry. You have to give a shout out to Brian and the Apache Tomcat team. So Brian Bellendorf and the Apache Tomcat team as well. So the Apache Tomcat team and the WebLogic team really wrote the J2E standard that Sun then repatriated and published as a standard. And then once they had the standard, they created the Java Community Project and the JSR, the Java Standard Review Process. But all of that was bolted on. They didn't start with an open source community. So I think the governance dynamics are very different because Java was not a proper open source project. I think where the parallel is the same is the adoption of Java wildly accelerated once J2E was released because you could start to build tools. And if you were a tools vendor, you knew if you built your tool in a way that conformed to J2EE, it would work against any app server or any application. So it dramatically scaled the ecosystem. So that's something we want to replicate. But the community management aspect of it was a first generation. And you've got to also remember, in 1997, open source didn't exist yet, right? Not really. You had GNU, and then you had Linus, And Linux was not yet, it wasn't yet the Linux Foundation, and Red Hat was only just starting up. So I think some of the dynamics of governance and contribution are very, very different. But some of the parallels about interoperability, scaling the tool and infrastructure community, allowing application vendors to write to a specification and have certain it will scale in the infrastructure, those are things we definitely want to achieve.
Chris Berniski, Arc Invest. I like this idea of single chain, but I'm curious as to what you mean by running certain instances behind a firewall. And the reason being, when you think about a public network, as Ethereum currently stands, or Bitcoin currently stands, you have all nodes within the network syncing the same information. And so I'm curious, I mean, I understand with sharding, this will change somewhat, but I'm curious, are we talking about, using ZK snarks for obfuscated transactions? And so as much detail as you can give about how you would run, and I get it, it could be an analogy, but firewalled implementations.
So the part that is respective to public versus private is the notion of pluggable consensus. The idea that you can swap out the consensus algorithm based upon your environment. So I mean, everything's a trade-off. And if we're in a permissionless network, we'll need a proof of stake or a proof of work, versus if we're in a permission network with a regulator, if it's 3 counterparties and a regulator, you could have a PBFT or something else like that, and the ability to swap out that consensus algorithm will give us the ability to go private or public.
You should probably ask that question again this afternoon when we have Bob and Shahan and Heiko on that. I guess what I'm saying is, I don't mean firewall in the traditional block off all the IP addresses and don't let anyone in. I mean, today, people are running virtual networks over the internet, right? Banks run processing over the internet with other banks. They use it as a network, right? And they connect it. But they create I hate the term, but they create a safe space on the internet for sensitive data, right? And so that's one principle, that you're going to want to create safe spaces within these networks in which the data and the transactions are protected. Now, protected means a combination of privacy and permissioning and other things, but where it's protected, I think people would fundamentally agree with that. But the second point the second point to this is just, I think it's important to understand that what internetworking really means, which means the way you build a globally scaled networks achieve scalability is by interconnecting networks. And sharding is an example, effectively, of internetworking, right? Where you're going to have subnets that are able to process separately and then connect to each other, right? That is literally how the internet works. And so I think the idea that you need these public protocols so you have interoperability is fine, but you're going to end up with sub-configurations within the network, right? Toyota does not necessarily want their supply chain details being visible to Ford, right? But they both benefit from being able to run the same software in different configurations.
Sandra?
Changing the topic slightly, going back to what EEA is really about being for enterprise. Can you hear me? Okay. Can you talk a little bit about, what you envisage over the next 6 months to a year in terms of bringing in other industry, and you take a look at what the initial membership is, quite diverse, from fintech, consulting, financial services, but actually could argue it's a little bit light on other industries.
Sure. So this is the tip of the iceberg. This was the bare minimum just to get us off the ground. We have had tremendous interest horizontally, healthcare, supply chain, natural resources, and the notion here is that each of these enterprises should not be tweaking Geth, taking out proof of work, and playing at that protocol level. And you're going to hear from some of the most intelligent minds that are going to be doing that, for them. And we're going to be operating vertical specific working groups. So you could imagine kind of the smart Ethereum electronic medical record, or a smart bond, or a supply chain workflow. And we're going to have global collaboration I imagine the list of brands will be doubling in short order, and it will be. It has been heavily financed initially, but everybody else is going to be joining.
And I think in part the initial member list was influenced by who's really built a lot of blockchains already and who's built the existing blockchain consortia. And there was just this little knowledge advantage in some of the financial institution innovation labs. But, you know, that's not the end goal. The end goal is pervasiveness.
Yeah, can you just mentioned yourself that most of these companies are tweaking Geth and using Geth. So can you talk a little bit about the decision to use Pi Ethereum instead of the more robust and more widely adopted?
Sure. So
Ethereum?
Haiku can talk about that this afternoon when he's on the panel. You want to do a comment, or do you? I'll do a comment, then Andrew do a comment. Vitalik hacks Pytherium. That's probably a pretty big driver. We will be doing a lot of work on Geth. We will be doing a lot of work on Quorum. And so one of the things that Bob, if you've been following in the Slack channels, has mentioned a number of times is there's no such thing as interoperability and pluggable consensus if you only do it on one code base. So we have to maintain more than what we... Maintain means something different in an open source context. We have to be using more than one code base to achieve the objectives. But the reason for Pytherium is it's probably the most advanced. It's probably it's the client on which more of the... Correct me if I'm wrong here, Haiku. Ethereum 2 is more of Ethereum 2 innovation is being developed on Pytherium than is probably the principal development platform for Ethereum 2 features. Is that fair? Yeah. So a lot of the early experimentation for 1.5 and 1.7.5 and 2 is happening in the Pytherium client. It happens that the code base could use a couple of good devs to help.
And I would just add from a pure licensing standpoint, I don't remember if it's MIT or Apache 2, but it's from kind of the more enterprise-friendly licensing families. And GPL as a reference architecture wouldn't necessarily be thought of as the right way to go to respect the enterprise's constraints.
But we'll be working on more than one code base.
Just to add a little bit to that, there will likely be more than one reference client. Pytherium will be chosen, I think, first to visit abstraction and modularity. Go is the dominant client, so we need to pay lots of attention to that. There's also a thrust to focus on validation of code, and that may not work so well on Pytherium. So we'll good chance we'll do that on Haskell or some other implementation.
And then this is all going to change when WebAssembly becomes prime time, right? I mean, so there are many, many more iterations to go through.
Over here.
Yeah, the right side of the room's been left out.
Okay, so let's get started. Let's get to work.
The video ready?
Yep.
All right, roll video.
All right, so long story short, Vitalik Buterin is at Mobile World Congress presenting today. He recorded this video for you yesterday, and it will be the Ethereum roadmap.
Hello everyone, I'm Vitalik, founder and chief scientist of the Ethereum project. So today I wanted to give everyone an idea and update of where the Ethereum project is, all of the really wonderful good stuff we've been working on over the last few months with the various Ethereum clients, research, development, privacy, ZK snark, sharding, proof of stake, all of that good stuff. And after that I also wanted to talk a little bit about the different ways that I think the Ethereum core development community and the enterprise community can work together with each other, and what some of the opportunities present. Into kind of one big monolithic project. It's actually even better to think of it as a collection of interoperating and interdependent, but at the same time still separate pieces. right? So you have the different clients. You have the Go client, the C++ client, the Python client. You have the research. You have the high-level languages. You have all of the work that we're doing on privacy. You have some of the research into EVM modifications, Whisper, Swarm, and there's people working on each one of those projects. So we have developers who are working on Go. We have developers working on C++, who are also working on the Solidity and some of the stuff around Solidity compilers. And we have some developers working on Whisper, Swarm. Over the last couple of months, we've really been pushing forward on our direction with zero-knowledge proofs, and we have people looking at that. And the research team is basically trying to figure out what the next versions of the Ethereum protocol are going to look like and get them to the point where they can be developed by all of the client developers. So as far as core client development goals, some of our goals are, first of all, optimization. So from an optimization point of view, basically we want to make sure that the Ethereum virtual machine runs as fast as possible, that we don't have any denial of service vulnerabilities, that thinking is as fast as possible, basically try to increase the blockchain's capacity as much as we can. And even outside of consensus, there's optimizations too in various other areas. Then bug fixes, safety improvements, that's always important. Denial of service, so that's an issue that we've had quite a lot last year, and that's definitely one thing that's continues to be at the top of our agenda. Basically, just keep on finding the part of the Ethereum protocol that's currently being processed the slowest and keep working on improving it until the worst problem is something else, and then start working on that. Light client support, that's something that we've made great strides in over the last year or so. So, we now have a functional Ethereum light client, and even I use it myself. But there's still quite a lot of work to be done. There's still work to be done just improving the quality, fully supporting mobile applications and so forth. Then Metropolis support. So Metropolis is our next major planned Ethereum hard fork. And there we have a bunch of interesting features around things like abstraction, things like integrating some of these ZK snark features and various other things. So that's got to be supported in the clients. Then very important testing and security audits. So we did a large round of security audits before we launched, and that's something that's a regular thing, and we continue to have audits that are ongoing. From a Solidity point of view, the main thing that we're probably focusing now is safety. So we've focused a lot on functionality in the first half of last year, but since then we've pivoted quite a bit to trying to just make sure the language is as hard to screw up with as possible. And part of that is various language features, part of that is warnings, part of that is that we have one developer, Yuichi, who is working on various formal verification features. Then Christian is adding an intermediate language, so something that Solidity compiles into before the EVM. And this will help in enabling optimization, making the compilation process kind of more transparent, assisting in debugging. Then we have Remix. So last year we had Mix, which is our IDE that we designed for developing Solidity contracts, but now Remix, so we're basically moving the IDE over into JavaScript. So Ethereum doesn't just exist in isolation, it exists as part of this kind of integrated Web3 vision. And beside Ethereum, we have these two sister projects, Whisper and Swarm. And so Swarm is a distributed content store. So just stores data, key value map. You upload data, data goes up, and if you want to download a piece of data, you would get the hash, use the hash, and fetch the actual piece of data from the network. And the kinds of use cases this was intended for, first of all, there's a lot of applications that only need to store the hashes of data on-chain instead of storing the whole data. So this would be situations where the entire data is just too large, where you'd want to not store the whole thing for privacy purposes. And generally in those cases, what you want to do is you'd want to store the actual data on Swarm. Now, if you have privacy needs, then obviously when you store the data, you'd also want to encrypt it. But that's one thing that you can use Swarm for. Another thing is storing the user interfaces of dApps. So this would be HTML and JavaScript files. So for example, over here we have a bulletin board that's designed right now just on top of the Ethereum blockchain. So every message is a transaction, but eventually something like this could be done kind of more fully over Swarm and Whisper. And here it's using Swarm as a way of hosting the interface, right? So there's no actual single server that this decentralized application relies on. Whisper peer-to-peer messaging. So it has probably two major categories of use cases. One of them is privacy-preserving communication, and the other is in other kinds of blockchain protocols where you also have to use a combination of on-chain and off-chain techniques, right? So if you look at something like state channels, for example, passing around off-chain data is something that has to happen. So not every kind of message goes on the blockchain, and every message that doesn't go on the blockchain, how do people actually transmit them to each other? So Whisper is the protocol for that. In some cases, you might have protocols for decentralized exchanges where orders get passed around. So lots of use cases there. So research, the major goals here are designing future versions of the Ethereum protocol. Right? So the next major release that we have is Metropolis, and we'll talk about a couple of the features of that very soon. But aside from that, there's Proof of Stake, Casper, and Casper includes some kind of bottom-level research into distributed consensus theory, some research into crypto economics, which I gave a couple of presentations about recently. And it includes designing the actual algorithm, figuring out the roadmap, making sure that the algorithm works correctly, building simulations, building test networks, and eventually hopefully getting to the point of releasing. Scalability and sharding is a bit longer term. So there are some things that we can do in parallel. So we can look into erasure coding, we can look into the same sort of basic kind of crypto economic research, asynchronous programming models, so that's the sort of thing that would be useful for cross-shard communication. But part of the roadmap really does depend on proof of stake, basically because the way that the sharded consensus will look ultimately depends very heavily on what the kind of non-sharded base layer consensus looks like. So this is what I kind of aspirationally, I guess, view as our research roadmap, right? So in general, first step is always to determine the goals. So in our case, the goals are scalability, reducing the cost of the consensus algorithm, making the consensus algorithm have stronger properties, things like economic finality, things like general kind of economic incentive compatibility, fault tolerance. Then from there, come up with a solution path, so come up with some proposal for an algorithm to solve the problems. Then from there, analyze it further. We do a bit of internal peer review, and sometimes if we have a big idea, the research team might even organize kind of internal mini workshops like we did back in Singapore in November. And there are two possibilities that could come out of this, right? One of them is that we discover the solution path is flawed, in which case we come up with a different one. Another possibility is that we discover the solution path is flawed, but part of that is discovering a new goal, right? So part of that is realizing, wait, these properties aren't enough, we also want to have these other properties. And if that's the case, then you go back to the determine goal step. So then afterwards, analyze further internal peer review. If that passes, then the next step is to prove the concept using a kind of minimal simulation. So the idea here is not to make a kind of full-on simulation with a full-on kind of real-life network or even a full-on version of the Ethereum protocol, but just a quick simulation in Python that shows nodes that kind of talk to each other over a simulated network, and that shows that they can all come to consensus, that shows that it has the desired properties. And this might have a couple outcomes. First of all, the process of proving might make us realize that there is a flaw, or we might discover that the development complexities and the implementation complexity is too high, and that requires us to simplify. Or alternatively, hopefully the concept proving passes and everything still looks fine. At the same time, we also are starting to do some formal verification. So, for example, last week, and actually a couple of days ago, he released a blog post. Yoichi did some formal proving on a fairly keystone piece of Casper. So basically proving that it has some of the safety and liveness properties that we expect. Then if that passes, then we can create any kind of integrated single node simulation. So include everything, just like build a complete implementation in Python and have it talk to itself over a simulated network. Then after that, go from a simulated network to a real network across multiple nodes. Then implement and test across all clients. And actually, all the way through this process, the kind of analysis and the internal peer review, and then has some external peer review as well. Hopefully, continues. If we discover some flaw, then yes, there's some work that will have to be thrown out, and we have to go back to the drawing board a bit. But hopefully, that doesn't happen. Create a test network, then implement and test across all the clients, and then release. Right? And all the way through this path, there are, of course, ongoing security audits. So Metropolis, so here's just a sample of some of the things that we want to do during Metropolis. So one major Ethereum improvement proposal that we're introducing has to do with this thing that's called abstraction. And the idea with abstraction is that it allows sending unsigned transactions from a special kind of entry point address. And the purpose of this is that to basically move signature verification from being a part of the protocol to being a part of EVM contract code, right? So the benefit here is that instead of kind of being stuck in one particular way of verifying transactions, people can, if they want, make their own kind of verification functions for their own accounts. You can get rid of nonces, you can implement a UTXO scheme if that's what you want, you can implement a better signature scheme, you can implement a quantum safe signature scheme, you can implement a much better version of multisig, and so forth. Contract address being based on the code hash, so you can send to contracts that don't yet exist, and any account in the call execution chain can pay for gas, right? So people always want, not just the sender, but also the recipient to be able to pay for gas. This has some important convenience benefits, and it also has an important privacy benefit because a lot of kind of privacy-preserving schemes end up leaking data because of the accounts that currently has to pay for the transaction fee. But that's something that this is intended to fix. EVMification, so basically this is part of our roadmap of trying to simplify the protocol but try and move details into the Ethereum virtual machine as much as possible. In this case, move block hashes and state roots into the state. This allows for some client simplifications and direct hash links between distant blocks, so the fact that a particular block, let's say block number 2.5 million, contains a state root, and that state root contains the block hash of block 2.4 million. Those kind of very direct hash links between distant blocks actually allow for much more secure and much faster light client syncing. So you could imagine, light client just syncing the header chain in something like 10 or 20 seconds and getting the exact same level of security as a full node, as a light client does now, right? So it's almost the same as a full node because 51% attacks can do a bit more, but it's quite close. Modular exponentiation. So this is just a mathematical operation that's very important for verifying RSA and various other kinds of cryptography. It's useful for things like Oracle eyes, like in general applications that have to interact with traditional kind of legacy systems, whether it's finance, whether it's things on the internet, whether it's certificate authorities, whether it's something like the Estonian e-residence program. Like a lot of those end up using RSA as their signature algorithm, and so that's something that we want to support as well. Throw opcode. So basically, this is just a way of throwing an exception, but without consuming all remaining gas, right? So basically, the idea is that right now we have a lot of contracts that we notice developers developing that basically just throw if some condition isn't met, and you could imagine that condition not being met pretty often, and we just want to make that more gas efficient. Pairings and ZK snarks. So this is kind of the keystone from a privacy standpoint. So the general principle of ZK snarks, as I'm sure I've already talked about kind of ad nauseum, is it's sort of one of the kind of parts of the ultimate in privacy, right? So here the idea is that you can prove things about encrypted data without revealing anything about the data except for the claim that you're proving. So one very simple example is if, let's say, you send a transaction, and let's say we have a system where we want balances, we want transfers to be privacy preserving. So all the balances on the chain are encrypted, the values in the transaction are also encrypted, and we want the zero-knowledge proof that, first of all, we have enough money, so the value of the transaction is less than your balance, and second, the new balance actually is the correct new balance. Right? So the new balance is the old balance minus the amount that you're sending. Right? So in general, if these values are encrypted, then it's kind of hard to see how the blockchain can actually verify that the transaction is legitimate. But with ZK Snarks, you actually can do that. Right? So last year in July, we had a workshop at IC3 or with IC3 at Cornell, where us, in collaboration with some people from the Zcash team, created this precompile for ZK Snarks. So this project is called Baby Zoe. I mean, you can find out about it online. There's a blog post from like August. And the idea just is a simple integration of ZK Snarks into Ethereum. And so since then, we've kind of advanced a lot in terms of the approach that we're going to use to do that mathematically. So instead of directly integrating the full specification for zero-knowledge proofs, we're only going to integrate what's called elliptic curve pairings, which is the single most computationally intensive component. And the reason we're doing this is to allow people to potentially use like various different zero-knowledge proof schemes if there end up being optimizations. And it's also just simpler and safer from a consensus standpoint. Pairings, I mean, this is just very spooky math. Bilinear maps. If you want to learn more, talk to your friendly neighborhood cryptographer, or read that Medium post that I wrote a month ago. So, next question, how can the Ethereum core development community, the Ethereum community, and the enterprise community collaborate? So, first of all, a very large portion of enterprise applications end up using permission chains, and they have various reasons for doing this, whether it's scalability, whether it has to do with their privacy model, whether it's because they see permission chains as being kind of less spooky from a regulatory perspective and easier to just get people to go along with. But in general, this is something that a lot of people are doing. So there are differences between the two, right? So there's not kind of a perfect match. So one example is that public chains rely on crypto economics. So public chains rely on in-protocol incentives that have to do with adding and subtracting token balances. So either giving people ether or taking ether away as a way of guiding participants in the protocol toward good behavior, right? So if you're a good boy, then you get a block rewards and transaction fees, and if you're a bad boy, then your deposit gets destroyed. I'm sure people have heard Vlad talking about this. I'm sure people have heard myself talking about this. This is what proof of work relies on. This is what Casper relies on, although in somewhat different ways. But this is how public chains get their security. Permission chains rely on existing social and institutional trust and social and legal penalties. So one phrase that I like is that it's proof of stake where the thing at stake is your banking license. So nodes, right? So this is one major technical difference, which is that public chains must be accessible to a user with a consumer laptop, right? So public chains are kind of meant for the common people, and they really needs to be kind of as accessible to just regular average Joes as possible. Now, of course, Ethereum clients are practically speaking still a bit too difficult to use for actual average Joes to be able to use them, but this is a goal, and it's important that at least from a hardware standpoint, at least from a standpoint of the blockchain being possible for a user to process, this is satisfied, right? Now, permission chains, you can kind of scale the dumb way, right? So permission chain nodes can run on more powerful servers. Permission chains generally run in kind of private networks, so people can't connect to them through the public internet, and you can get higher bandwidth. Then you can also process more transactions a second because the servers are more powerful. Then because the connections are better, because you have fewer nodes, you can have faster finality. So you could imagine finality happen within, let's say, 3 seconds instead of 3 to 30 minutes. And also the data model. So there's people that are experimenting with various models that have to do with the kind of chain state being private. And in a public blockchain, at least right now, the public chain state has to be accessible to everyone so that everyone can verify it. in this permission model, it can be encrypted between a few parties, and Court is doing something like this, Quorum is doing something like this. In the future, you might be able to extend this with techniques like state channels and ZK snarks, but that's kind of still a bit in the future. So, public blockchains in enterprise, there are some companies that are okay with working on public chains, and this has benefits. So, you can leverage existing infrastructure, you can leverage, things like Etherscan, things like just the integration of various development environments, reduce the cost. You don't have to maintain your own chain. You don't have to do the kind of security work around your chain to make sure that it's trustworthy. Interoperability with other applications. I mean, there are serious costs to doing this, right? That are driving a very large number of enterprise users to stick with the consortium model. But for some applications, it turns out that these costs are bearable. So basically, what we really want to do is we want to, first of all, try and leverage this benefit that a lot of the infrastructure and a lot of the challenges can really be shared between the two models. And also, there's this kind of common problem that you want to build bridges between either Ethereum or the EVM and kind of legacy infrastructure. And that could include financial protocols, it could include things that have to do with certificates, it could include, as I mentioned, the Estonian e-residency program, lots of various things. So, similarities, right? So, similarities between the public and the permission setting. First of all, there's the need for a virtual machine. Second, there's the need for scalability and performance. Then you have higher level language concerns, smart contract safety. Scalability is a major one. So, parallel transaction processing is the simplest way for permission chains to scale. Public chains can use it to a limited extent, but then if you want to go further, then you would have to kind of combine the parallelization with a sharding scheme. Then, from the point of view of just kind of very short-term incremental optimization, Ethereum virtual machine, I/O, so reading and writing from the state, and networking, so passing messages as quickly as possible. Then resistance to denial of service attacks. And that's kind of similar to optimization, although there's a bit of a difference because you can think about optimizing the average case versus optimizing the worst case. And if you're going to use an Ethereum chain to run some particular application and you can control what contracts there are, then there's some kinds of DOS resistance that you're not going to want, and you might want some different kinds of optimization. But in many cases, the challenges are shared, right? Privacy. So in both settings and in general, there's this trade-off between privacy and verifiability, right? So if you have a particular set of nodes that is involved in verifying something, then they have to see it. And that's a cost from a privacy standpoint. Now, there are these fancy advancements in crypto that can try to solve the problem, but that's still kind of a bit in the future. Also, another way of solving this problem is to use a smart combination of on-chain and off-chain messaging. So things like state channels are great. Things like storing the hash of a piece of data on the blockchain and keeping the rest off-chain is great. Storing encrypted data in the state and storing the decrypted stuff somewhere else is great. So, there's lots of ways to try and whack at these different challenges. And, look, this is a common interest. So, in general, I think there's a lot of things that we really can work together on. So, we have a lot of these kind of shared challenges, a lot of things that, if they get solved in one context, the solutions can be ported over into another context. And, I hope that we can work together on some of these challenges. I hope that, we can, the Ethereum core development community and the kind of enterprise community can, in as much as we can, kind of put their forces together and see if we can come up with solutions to some of these problems and hopefully build great technology to make the world a better place. Thank you.